Question 8. So let's kick off by putting all the forces onto the diagram. So the weight of A is 2 mg, a normal reaction of R, and then the friction in the opposite direction to the movement is mu times the normal reaction. It's obviously going to be accelerating left to right, and this one's going to be accelerating at the same speed downward, same rate of acceleration downwards, and then B's got a weight of mg. And then remember the two tensions with the arrows pointing towards the pulley. So for part A, write down an expression of motion for A. So just looking at A and resolving left to right, using F equals ma as our starting point. Well, our net force is the tension less the friction, so T minus F, and that equals equals the mass times the acceleration, so the mass of 2m times A. So that's our equation number 1. And then for A part 2, so moving on to writing an expression for B, resolving downwards here, but again using F equals ma as our starting point, our net force is mg minus T, and that equals ma, where the mass is m and the acceleration is A. So that's our second equation. Now for part B, when we've got to show this, we're going to start off by working out what the friction is, so we can substitute that up into our equation 1 up here. So friction equals mu times the normal reaction, and then our normal reaction is going to be equal and opposite to this weight of 2 mg. So our friction is going to be mu times 2 mg, so 2 mu mg, and I'm going to call this equation 3. Now I'm going to take this equation 3 and substitute it into my equation 1 up here, so replacing the friction with 2 mu mg, giving me this revised equation, which I'm calling equation 4. So now focusing on equation 2 and 4, if I add these together, I will eliminate the tension because I've got a minus T in this one and a plus T in this one. So I'm choosing to add these two equations together. Okay, so that gives me mg minus 2 mu mg equaling, with them added together, 3 lots of ma. Now because m is common to all three terms, I can divide through by m, and then factorizing I get this, and dividing through by 3 I've shown that acceleration equals g over 3 multiplied by 1 minus 2 mu. Now for part C, I'm being asked to find in terms of g, h and u the speed of A at the instant when B hits the floor. So what speed is A going at as B hits the floor? Or in other words, what speed does B hit the floor at? So what I'm going to do, I'm going to just concentrate on B really, because how that hits the floor, the speed it hits the floor at is the same speed as A is travelling as it hits the floor, as it's an inextensible string, it's not stretchy, so they've got to be travelling at the same speed. So using v squared equals u squared plus 2as, I'm trying to work out what v is. I know my initial speed before the whole thing starts moving is 0. I know my acceleration from what I've just part B of the question, and the distance that B is travelling is h. Okay, that's the distance it's travelling is h. So substituting that in, I get this. So then square rooting both sides, I get v equaling this. So that's my final answer for part C. Now for part D, after B hits the floor, A continues to slide along the table. Okay, so think about it. So we've got A sliding along the table. The second it hits the floor, it's going to carry on hurtling along here at a different acceleration. Okay, so I need to find out this the new acceleration that it will be accelerating along at. In fact, it will be decelerating, but it's going to be carrying along on here, decelerating. But what's important to take on board is its initial speed for this second journey, if you like, is the same as the final speed just before B hit the floor. So anyway, I'm going to be using v squared equals u squared plus 2as, but I need to work out what my revised acceleration is, or deceleration as it's going to be. So again, using f equals ma and resolving to the right, the only force in town now is going to be the friction that I'm fighting against. So that's going to be minus mu times r, because obviously that's in the opposite direction to my movement, and that equals my mass of 2m times my revised acceleration that I'm calling a dash. So then substituting in that the normal reaction is 2 times mu times mg, I can substitute in that my mu is a third, and obviously my normal reaction is 2 mg. My normal reaction is 2 mg. Okay, just going over that again. All right, so my friction is minus mu, so minus a third, times my normal reaction, which is 2 mg. So that's my net force, and that equals my mass, which is 2m, times my revised acceleration a dash, and then cancelling or dividing through by 2 and dividing through by m, I can see that a dash must be a minus a third of g. So I'm decelerating as I carry along here. So now using v squared equals u squared plus 2as, okay, I've got a initial speed. My initial speed is going to be the final speed before B hit the floor. So that's my answer from part C. So my u squared is going to be this v all squared. So that's just basically undoes the square root. So that's my u squared there, plus 2 times my revised acceleration of a minus a third g, times the distance I'm travelling. Now the distance I'm going to be travelling up here is going to be the difference between d and h. So it's going to be d take away h. That's my distance travelled. So that is that equation there. Now I'm then just taking this second term over to the left hand side, gives me this here, and then an awful lot of stuff cancels out now. The 2, the g, and the division by 3 cancels out, giving me at this point a third of h equals d minus h. Then adding h to both sides, I get d equaling 4/3 h. So that's my final answer for part D. Now for part E, describe what would happen if mu equals a half. So going back, what would happen if mu equals a half? Well, we're using this 1 minus 2 mu. Alright, now if mu is a half, then that's going to basically equal 0. So the whole thing is not going to be moving. Okay, A would not move. Now what I've done, I've just included a snapshot out of the answer scheme so you can see how you could have actually, what you could have written, because there's a number of different options you could have written down to get the answer for part E. But in short, if mu is 0, the friction is big enough that A just wouldn't move.